Good afternoon. Just looking into section R8 for what we have regarding inequalities. Okay, and we're going to start out again with just the general inequalities, and then we will look into inequalities as they pertain to absolute value expressions. And from this section, okay, we're looking at solving for x in the case of problem number 9, and we have for the statement, we have that negative 2x minus 5 is greater than 17. And looking at solving for x, okay, now you're going to isolate the x term just as you would if we had an equation like negative 2x minus 5 is equal to 17. Okay, and so as we look at proceeding, okay, so looking at isolating negative 2x, okay, so we can add 5 to both ends. And for what we have now, okay, so upon adding 5, okay, so left-hand side, okay, we have that negative 2x is greater than 22. Okay, and again, so you have a negative variable expression. And some things to remember, again, for working with negative coefficients, okay, if I'm multiplying or dividing by a negative, okay, and this is the part that is so easy to overlook, but again, whenever you're multiplying or dividing by a negative, the direction of the inequality changes. Okay, so again, so if you multiply or divide by a negative, again, you have the direction to change. All right, so we have for negative 2x over negative 2. Okay, so that is going to be x. And we have, in turn, okay, so we're going to have the x is less than negative 11. Okay, so this is going to be our inequality solution. Now for this particular set, okay, we're looking at 3 modes of expressing the solution. Okay, and say we have, like in the case of graphing, say for a graphing solution, and I'm just going to do a bit of a quick sketch. Okay, so we have for graphing, okay, so we have the x is, again, less than negative 11. Okay, so if you envision or set up a number line, okay, so you have like negative 11 is going to be the centerpiece. Okay. And for values greater than negative 11, you have to the right, and those less than we have to the left. Okay. And looking at the graph, okay, so you have x is less than negative 11. Okay, and so with no equal sign, negative 11 is not going to be part of the solution set. And you can symbolize this in the graph by applying a circle. And then for the solution itself, you're going to have those values less than negative 11. So you have like including negative 12, negative 13, and so on. And you would have, in this case, array that is going to go continuously out to the left. Okay, and with a non-stop motion, okay, we're looking at heading out in the direction of negative infinity. And then we have with the other mode, okay, this is what is referred to as the set builder notation. And for the set builder notation, this is just using grouping symbols to denote sets, and it just basically repeats the inequality solution. Okay, so in this case, for the set builder notation, okay, you have braces for the grouping symbols, and your opening statement is going to be with the variable you're solving for, followed by a vertical slash. And this will be read like the set of all values of x such that, and then we fill in the inequality. So we have that x is less than negative 11. And for what we have now for the interval solution, okay, those are your statements with parentheses and potentially brackets. And for what we have for x is less than negative 11, so we have a one direction inequality where we have moving to the left. And for interval notation, you're going to read from left to right. In other words, from the smallest to the largest. Okay, so we have at the lower end, we're going to have at negative infinity. And at the upper end, we have approaching but not including 11. Once again, for interval notation, whenever you have infinities, infinities are boundless, and we maintain the use of parentheses. And because negative 11 is not included, you have like representing like up to 10.999, but never getting to 11, you have the parenthesis around 11. Okay, so these are three distinct ways of how we say that x is less than negative 11. All right, now changing up the variable, and we have for number 10, okay, and we're looking at the equation in terms of the variable t, whereupon we have negative 8t plus 1 is less than 17. Okay. And if we look at isolating the variable term, okay, in this case we have a negative 8t, so I can undo the addition by 1, okay, upon subtracting that value from both sides. Okay, and so we're going to have in the rewrite, okay, so left hand side, okay, we'll have negative 8t. It's going to be less than 17 minus 1, which will be 16. And okay, so we have a different letter, but our variable term is negative. And we're going to have again the bit of history of dividing by a negative to repeat. And once again, so we're going to change directions. Before we had less than, and with multiplying or dividing by a negative, again, we have the direction flips, in this case from less than to greater than. Okay, so for what we have on the left hand side, okay, we have t, and we have is greater than, and 16 over negative 8, okay, will be negative 2. So this is going to be the inequality solution. And again, just looking at displaying what we have with our modes of expressing the solution. Okay, so we have for t is less than negative 2. And just like negative 11, okay, negative 2 is not part of the solution. Okay. So with negative 2 excluded, again, you can have either a parenthesis or an open circle. And for what we have in terms of the activity, okay, for the solution, okay, we have greater than negative 2. Before we had less than, where we had a ray going to the left. Now with greater than, we have a ray that is going to go continuously to the right. And for the action that we have here, the continuous motion, in this case non-stop increasing, we have t going in the direction of infinity. And just for the set builder form, again, this is just restating the inequality solution and just grouping around the set notation, grouping symbols. Okay, so in this case, we have what's going to be the set of all values t, such that t is greater than negative 2. And for the interval display in the set, okay, so we're going past negative 2 on out to infinity. Once again, infinities are boundless, so upper limit will be in parentheses. And since negative 2 is not included officially, we have a parenthesis around that. So you have another case of an open interval statement. All right. Now, for what we have in the case of 16, okay, this time we're going from solving for x to solving for t, and now we're looking at solving for the variable m. And for this inequality, okay, now we have in the presentation, okay, we have negative 14 is less than 3 times the quantity of m minus 7 followed by the addition of 7. Okay, and so we have again, so we have an m expression as part of the binomial, and to free up from the parentheses, okay, we're going to be looking at distribution of 3 over the quantity of m minus 7. And so taking the parentheses out, right now we're going to have negative 14 is less than 3m minus 21 followed by the addition of 7. So we have constants to combine. So we got negative 14 is less than, and then we have 3m, and negative 21 plus 7 becomes negative 14. Right now we got the m term on the left, on the right. But I'm going to move it to the left. Okay, so you got negative 14 is less than 3m minus 14, and isolating the variable term. Okay, so upon adding 14 to both sides, okay, so we have additive inverses will cancel. Now we have that 0 is less than 3m, and expressing in terms of m, okay, now we're going to be looking at division by 3. Okay, and notice we're dividing by a positive constant. Okay, so you're not going to have the direction of the inequality to automatically flip. Okay, so we got that 0 is less than m, and just maintaining the logical consistency. See, if I put m on the left and still preserving that 0 is less than m, this is going to be the same as saying that m is greater than 0. Kind of like if 0 is less than 1, 1 is greater than 0. And again, just for what we have in the case of graphing, okay, so you have that m is greater than 0. So m is going to be the set of all positive real numbers. And so we're going to have a ray that will go continuously to the right. And this will be in the direction of heading off to infinity. All right. And just for the set builder form, and so we have the set of all values of m, and again, repeat the inequality, okay, whereupon m is greater than 0. And for what we have in the case of the interval notation, okay, so you have the activity occurring around 0, and again you have continuous increasing. And for the grouping symbols, again 0, just like negative 2 and negative 11 from the earlier problems, is not going to be included, so we still are going to be applying parentheses. And again, infinities are boundless, so we have yet another open interval layout. Okay, now we will cross over to where we will have closed interval sections, and the next item we're going to have such situations. And for what we have in looking at combining inequalities, or at least looking at some of the commonalities between them. Okay, there are two key words that we have here in terms of combining intervals or sets, at least in the language of inequalities. And we have with the linking word and. Okay, this is going to be focusing upon exclusively what is going to be shared between inequalities. And for the other conjunction term, okay, we have or. And instead of focusing or limiting to only what will be shared between the inequalities, you'll be looking at combining everything. We're talking about everything, regardless of whether the elements are shared or not. From the inequalities. All right. And where we have the terms involved, okay, and say for number 27, okay, say if we have individual inequality statements, and we have the first, okay, so we have that x is less than 4. And the second, we have x is greater than or equal to -2. Okay. And looking at what we have here, and sometimes graphs can provide a helpful visual. Okay. And we'll say that for x is less than 4. Just kind of doing a very brief sketch. You have x is less than 4, so 4 is not included, so you have an open circle. And then you're going to have, for less than, you have a ray going continuously to the left. And for what we have in the case of x is greater than or equal to -2, okay, this time we got the equal sign, and this is going to signify that -2 is included. You have x equal to 2. Solid point indicates the equal to 2 portion. The rest of the values you have greater than 2 or -2, and you have going continuously out to the right. Okay, now for what we have in terms of the combining terms, okay, and we have for the first part, okay, if we're looking at the set of values whereupon x is less than 4 and we have that x is greater than or equal to -2. Okay, and again, with the linking word and, you're looking at what will be shared between the inequalities. Okay, so if you notice, okay, in terms of any overlapping, okay, so for what we shared, okay, so from the first inequality, there will be nothing 4 or greater. And from the second inequality, there will be nothing that is less than -2. If you notice, you have the directions moving in crisscross fashion. And for the values that will be in common, okay, we have including negative 2, because negative 2 is less than 4, and we have from the upper limit the peak will be the highest value that is less than 4. So in terms of what is shared in common, will be signified by this particular line segment. Okay, and so in combining, okay, so you have x is greater than or equal to negative 2 while also being less than 4. So if you're looking at consolidating with this line segment, we say that we have negative 2 is less than or equal to x, which in turn is going to be less than 4. Okay, so just kind of drawing this out. Okay, so if I switch the order, like x is greater than or equal to negative 2, and x is less than 4, and again just switching it over, x is greater than or equal to negative 2 is the logical equivalent of saying that negative 2 is less than or equal to x, and x is less than 4, and so just piecing together. So you got negative 2 is less than or equal to x, and you got the same x to be less than 4, and so you have this consolidation. And so for the interval solution, okay, negative 2 is less than or equal to x is less than 4 is going to be the inequality solution. But for what we have in interval terms, again, we're working around negative 2 and 4. Thanks to the equal sign, negative 2 is included. So that is going to be in the bracket with x less than 4. Never is 4 included. And so that is going to be in the parenthesis. All right. Now, in terms of, say, with the same inequalities, and this time, if I have that x is less than 4, or x is greater than or equal to negative 2, okay, so I'm shifting gears, going from and to or. And so for what we have here, again, or you're looking at combining everything from the inequalities, regardless of the values that are shared or not. Again, so we worked around 4 and negative 2. You have values of x less than 4. And if I combine with values of x greater than or equal to negative 2, guess what? 4 is going to wind up being covered. And so for what is going to wind up happening is that you're going to have everything between negative and positive infinity to be covered. Okay, so anything that x is less than 4 lacks is going to be compensated for by x is greater than or equal to negative 2, and vice versa. And guess what? We have for the entire stretch, okay, we're coming out to the set of all real numbers. So you have continuous expansion in both directions. And it's going to turn out that since we have all real numbers, again, the interval solution will be that which defines the set of all real numbers. In this case, we have parentheses around negative and positive infinity. All right. So that's the fine line that distinguishes and apart from or. And you're looking at limiting to only the shared values. With or, you're looking at combining everything that exists between the inequalities. And we have kind of a similar run in, say, if we have a number 28, and we have this time in the variable y, now which the author is stuck with the letter x, okay, but y we're looking at just a horizontal display, not like the vertical axis. Okay, so you have y is less than or equal to -2, and for the other inequality we had that y is greater than -5. Okay. Okay, so for what we have regarding y is less than or equal to -2 with an equal sign, okay, -2 is included, everything else is less than, and so we're going to have a ray going continuously to the left. And for what we have in the case of y is greater than -5, okay, so -5 is not included. So you have an open circle. And we have a ray going continuously to the right. All right. And again, we have with combining the terms. Okay, so we have y is less than or equal to -2 and y is greater than -5. Again, looking at the values that will be shared in common. So nothing is going to be to the left of -5, and nothing is going to be to the right of -2. Okay, so you have at the ends, you have the open circle on -5. At the upper end, we'll have a close point on -2. And so we're going to have, in this case, again, we have a line segment. And so for once we combine, again, we're going to have like an inequality, compound inequality, where in terms of the readout, if you were to join together, you would have that -5 is less than x, which in turn is going to be less than or equal to -2. Yeah, we're working with y. Okay, so I have -5 is less than y is less than or equal to -2. And once again, for what we have with the statements, so I've got y is less than or equal to -2, or y is greater than -5. So everything from both the inequalities will be graphed. It looks like we'll have partial history to repeat. It's got -5. again, -2. And we have everything to the right of -2 this time around, and values from -5 on down will also be in the mix. And we're back to the set of all real numbers. Okay. All right. So we have, at least with the word or, okay, the result is a set of all real numbers. Again, we're going boundlessly between negative and positive infinity. And for what we have with -5 is less than y is less than or equal to -2 for that interval solution. Okay, so you have -5 is less than y is less than or equal to -2. And again, with the lack of an equal sign alongside -5, you have a parenthesis, and with the equal sign included next to -2, -2 is going to be in the bracket. All right. Now, so these are cases of what we have with general inequalities. Now, looking at what we have in crossing over to what we have concerning absolute value. Again, the other day we had looked at absolute value equations, and we're going to cross over to inequalities. But just to tie in the previous lesson with equations, okay, say again, if k is a non-negative value, and we have, first of all, okay, if the absolute value of x is equal to k, then x could be positive or negative k. Okay. Now, for what we have regarding inequalities, if k is still a non-negative value and we have that the absolute value of x is less than k, all right, you'll be looking at sandwiching values of x, okay, between negative and positive k. And what's going to happen here, okay, is that we can, upon taking out the or removing the absolute value lines, okay, and freeing up x, you have x is going to fall between negative and positive k. So we have that negative k is less than x, which in turn is going to be less than k. Okay, and so that's going to be the same, okay, just a logical equivalent. Okay, so you have like x is greater than negative k, x is less than k. Again, just flipping it, we have negative k is less than x. And x is less than k. And just the interval notation for this, okay. So x is going to fall in this case between negative and positive k. All right, now next rule, okay, is going to be virtually a duplicate or duplication, okay. And we have with the next item, Okay, and if we have that, if we have this time that the absolute value of x is less than or equal to k, then we have a compound inequality where this time around you're going to have negative k is less than or equal to x, is less than or equal to k, and the interval notations for this, okay, since we have equal alongside negative and positive k, interval notation is going to have brackets surrounding these values. Okay, now in terms of what we have upon changing direction, if I have that k is non-negative and I have that the absolute value of x is greater than k, okay, what's going to happen here? Okay, remember, absolute value is the number of integral steps away from zero. Okay, and okay, so it's like the more negative a value is or the more positive a value is, the greater the distance will be from zero, and thus the higher the absolute value. So you'll be looking at extreme, almost like polar opposites. What's going to happen here, you're going to have almost like diametrically opposing situations. We have at the lower end, we have like x is going to be less than negative k. So this is one extreme, like increasingly negative. And then we have at the other extreme, you have increasingly positive. So you have x is less than negative k or x is greater than k. And for what we're going to have in the case of the interval notation, okay, what you're going to have to arise, okay, is that for what we have in, say, the negative zone, okay, on the minus side you have from negative infinity approaching but not including negative k, and this is going to be detached from the upper end, whereupon we have that x is greater than k. So to kind of signify the detachment, we'll have a U symbol. We have the next notation. Again, we have values of x greater than k. All right, and for what we have in the case of this variable u, we say that u refers to a union of sets or intervals. Again, just like case 3 is like a duplication of case 2, and we have like the remaining case would be almost like a duplication of case number 4. And this time if we have that the absolute value of x is greater than or equal to k, and this time we'll have the equal sign included in both scenarios. X is less than or equal to negative k, or x is greater than or equal to k. And the interval notation this time is going to be inclusive of negative k at the lower end and positive k at the upper. Okay, so these will be the scenarios that will be drawn forth in the case of absolute value. Okay, and just kind of draw up some inequalities that involve absolute value terms. And let's say that if we have just determine the interval solution of the following. Okay, and we'll start out with a couple of inequalities. Okay, we'll just say we have with the same terms. So we'll say we have the absolute value of x minus 1. First of all, okay, we'll say it is less than or equal to 7. Okay, so 7 is going to be the k value, and it's non-negative, and the absolute value of x is represented by the absolute value of x minus 1. So in terms of which of the 5 cases we're dealing with, okay, so you have like that which represents the absolute value of x is less than or equal to that which represents k. So this looks as if this is going to be summoning the third case here. Okay, so if you have this scenario, upon removing x minus 1 from the absolute value notation, then we have a compound inequality upon which x minus 1 is going to be centered between those numbers with an absolute value of 7. So those numbers with an absolute value of 7, we have negative 7 and positive 7. So we can now say that we have negative 7 is less than or equal to x minus 1. And we have x minus 1 is less than or equal to 7. And just looking at what we have here, okay, so I'm going to isolate x. Okay, so isolating x. Okay, so we'll add 1. And we'll add to all sections of the compound inequality. And for what we have in following through, okay, so you have negative 7 plus 1. Okay, so this will be negative 6. Negative 6 in turn is going to be less than or equal to x. And x, okay, is going to be less than or equal to 8. All right, so we have for the interval solution. Okay, so again we have so you have a containment between negative 6 and 8. Okay, so just kind of doing a quick sketch here. It's got negative 6 and 8. Where the equal signs, negative 6 will be included. So will 8. And everything else in between is also in the mix. So for the interval solution, okay, so we're going from and including negative 6 up to and also including the value of 8. Okay, so in this case, we're going to have a closed interval as denoted by brackets that will contain negative 6 and 8. Now let's say that if we have, in comparison to 7, let's say if I keep the absolute value of x minus 1 and say that this is greater than 7. All right, so you have like a absolute value of x and k relation. So we have here, okay, again, absolute value of x minus 1 is representing the absolute value of x, 7 is representing k, and with the inequality greater than, looks like we're going to have case number 4 to apply. And once you take out the absolute value notation, okay, so we're going to have inequalities going in opposite directions. And so for what we have in this case, have at the lower end, we're going to have x minus 1 is less than negative 7, or x minus 1 is greater than 7. Okay. All right. And so for what we have with the inequalities, Okay, so if I add 1 to both sides of both inequalities, so we have the x is less than, and negative 7 plus 1 is negative 6. This is the lower valued inequality solution. And for what we have in the upper realm, we have the x is greater than 8. Okay, and so looking at what will spring forth, notice we're still working with negative 6 and 8. Right. And since I now do not have the equal sign, both negative 6 and 8 will not be included. Okay, so we have with the extremes this time around, for x is less than negative 6, we have a ray that's going to go continuously to the left. And approaching negative infinity, whereas in case x is greater than 8, have a ray going out to the right and heading in the direction of infinity. Okay. And so for what we will have in the case of the interval solution, notice we have two graphs apart from each other, and so there's going to be a union of distinct interval sections. Okay, so at the lower end, we're looking at from negative infinity approaching, but not including negative 6. And we have at the upper end, we have those, for those values of x greater than 8, we have parentheses around 8 and infinity. And so that will be the solution of what we have in this particular case. All right, and now just some things here, and for what we have concerning absolute value. And let's say that if we have, this is just kind of a reminder for what to do if you're working with negative coefficients. And just to kind of keep these basic, let's say we have the absolute value of negative 2x is greater than or equal to 8. Okay. So I have here the absolute value of negative 2x is greater than or equal to 8. So you have the absolute value of x represented by that of negative 2x. K is non-negative, and it is represented by 8. So you have this next scenario to appear. Now, removing the absolute value notation, so you're going to be having as representative of x, you have negative 2x, and again we have with the cases set up, so we're going to have negative 2x is less than or equal to negative 8. We have at the other extreme, we're going to have that negative 2x is greater than or equal to 8. It's going to rewrite these. Okay, now, so you got negative 2x is less than or equal to negative 8. And again, I'm looking at solving for x. Okay, and I'm back in the terrain of dividing by a negative. Okay, so here you will have the inequality to change direction. So for negative 2x over negative 2, this will be x. So you have the x is greater than or equal to positive 4. For negative 2x is greater than or equal to 8. And we have upon dividing by negative 2, the direction of the inequality, again, is going to change. And this time we have the x is less than or equal to negative 4. Okay, so we got two extremes here. So we got the x is greater than or equal to 4, or x is less than or equal to -4. So we got this or statement. So the interval solution will be combining everything that defines these inequalities. Okay, so for what we have with the values, okay, so you got at the lower end we have -4. I'll say a 4. Both the inequalities have the equal sign. See, like for x is less than or equal to -4, -4 is included. And for this single inequality, again, we have action such that we have motion to the left and heading out to -infinity. And then we have with 4, thanks to the equal sign, 4 is included. All the other values in this statement will be greater than. And so you have a ray moving continuously to the right and approaching infinity. And so we have in the case of the interval solutions. So we have between -infinity up to and including -4. -4 is going to be in the bracket. And then we have with the other interval to link, you have from and including 4, which will be bracketed. And we have moving continuously out toward infinity. And again, infinities are boundless, and so those items will remain in parentheses. All right, and also if I have the statement that the absolute value of -2x is less than 8. So you have out of our cases, okay, so this is going to be application of case number 2, where we have absolute value of x is less than k. And once you translate in terms of a compound inequality upon removal of the absolute value grouping symbols, again, our k value is going to be at 8. And so we have in the setup, so we have -8 is going to be less than -2x, which in turn is going to be less than 8. Okay, so you got your -k is less than x is less than k, where k is at 8, and we have x represented by -2x. Okay. And so we're going to rewrite this to where we're going to have -2 in the middle. And guess what? I'm looking at division by -2. And since I'm dividing by negative values, okay, again, if you multiply or divide by a negative, okay, again, this is going to signify that the direction of any inequality immediately involved is going to change direction. So guess what? For both less than terms or inequality directions laid out from the previous statement, they're both going to change to greater than. So we have in the layout, we have -8 over -2 becomes 4. We have 4 is greater than x, which in turn is going to be greater than -4. And just putting in terms of increasing order. Okay, so -4 is at the lower end, and just flipping it in the rewrite. X is greater than -4, same as saying that -4 is less than x. 4 is greater than x, the same as saying x is less than 4. And so applying a visual, so yeah, between -4 and 4, neither -4 nor 4 will be included. And connecting the circles, okay, you have a line segment, okay. And so for the interval solution in this case, you have parentheses around negative and +4. All right. Okay. Now, for what we have in the case of the items, okay, pertaining to absolute value inequalities, okay, and we have just sort of holding over from what we have had in the case of numbers 48 and 58. Again, it's referring to our rules again. Okay, so we have in the case of the application of the rules. Okay, so we have where we have the absolute value inequality statements to come in, and we have from section R8. Now we have with number 48, now we'll have 2 times the absolute value. Okay, so we have 7 minus y, followed by the additional 1 is less than 17. Okay, and so when we looked at some of the equations, okay, we looked at isolating the absolute value expression. Okay, so again, just like in the case of equations, you don't treat the absolute value grouping symbols as you would the parentheses. So you're not going to distribute 2 over 7 minus y and say 14 minus 2y plus 1 is less than 17. So instead you're going to isolate, again, the absolute value of 7 minus y. So looking at what we have for the inequality, we can proceed, okay, by subtracting. Okay, so undoing the addition of 1, and we have upon subtracting, okay, so we'll have 2 times the absolute value of 7 minus y is less than 16, and I have the coefficient 2 to take care of. Okay, and again we have division, okay, not by a negative but by a positive, so we still have the inequality to remain in the mode of less than. Okay, so we got upon dividing, so we are down to the absolute value of 7 minus y is less than 8. Okay, so the absolute value of 7 minus y is by itself. So think of this as like the absolute value of x, and k is at 8. So we're back to case number 2. And so for that representing x, this will be sandwiched between negative and positive k. And so we're going to have a compound inequality. In this case, we have negative 8 is less than 7 minus y, which in turn is going to be less than 8. And just as we have isolated x, we're going to isolate y. Okay, so what we can do here, we can take care of the 7. Now we got negative 8 and negative 7 combining. Okay, we come out to negative 15. We have negative 15 is less than negative y. And 8 minus 7 is 1. And for expressing not in terms of negative but positive y. So I can either multiply or divide by a negative. So in effect, changing the sign values, we have changing the direction of the inequality portions. All right. So we have in following through, so you got 15 is greater than y, which in turn is going to be greater than negative 1. And if I look at rank ordering, okay, from smallest to largest, okay, so you have y is greater than negative 1 will be the same as saying negative 1 is less than y. 15 is greater than y will be the same as y is less than 15. Okay, again, due to the lack of equal signs, neither negative 1 nor 15 will be included. So you got a line segment. And just going ahead and putting in terms of the interval solution. So between negative 1 and 15, neither end values, or I should say neither negative 1 or 15 will be included. Okay, so the solution will be with the exclusive use of parentheses. All right, and for what we have in the case of number 58, and this time we're looking at the variable d. Okay, so here we got 15 is less than the absolute value of negative 2d minus 3 and see that is followed by the addition of 6. Okay, again we're going to isolate the absolute value term which we have to exist on the right hand side of this inequality. Okay, so if I take 6 away from both sides, okay, so you got 15 minus 6 is 9. 9 is less than the absolute value of negative 2d minus 3. And now the rules we've had with the inequality term on the left hand side, and I can do the same thing here, just kind of flipping. Okay, so 9 is less than the absolute value of negative 2d minus 3 will be the same as saying the absolute value of negative 2d minus 3 is greater than 9. Okay, and so we're going to be looking at upon removal of the absolute value bars, you'll have the polar opposite, or arguably polar opposite scenarios that Okay, we have at the extremes, you have negative 2d minus 3 is less than negative 9. And we have at the other end, you have negative 2d minus 3 is greater than 9. Okay. And so for what we have with these inequalities that are formed, okay, so with isolating negative 2d, and we have upon adding 3, so we have negative 2d is less than negative 6. And now that I'm looking at going back to dividing by negative, okay, so the direction of the inequality changes. Okay, so in this case we had the first inequality is going to translate, whereupon we're going to end up with d greater than 3. Okay, now for the other case where we have negative 2d minus 3 is greater than 9. Okay, so again, adding 3 to both sides. So we have negative 2d is greater than 12. Again, reapplying the division by negative 2. Again, we have the change in inequality direction, this time going from greater than to less than. So in this case, we have that d is less than negative 6. So for what we have in the layout, okay, so working with 3 as well as negative 6. Between the values, okay, we have negative 6 the lower, 3 the higher. Neither 3 nor negative 6 will be included. And for d is greater than 3, we'll have an array that's going to go continuously out to the right. And for d is less than negative 6, you have an array going continuously to the left. Okay, so for what we're going to have in the case of the interval solutions, okay, so for d is less than negative 6, which is now situated at the lower end, so we have parentheses around negative infinity and negative 6. And for what we have at the upper end, we have those values of d greater than 3. And again, the solution is going to be the union of these particular intervals. All right. And tell you what, just for cases that we have in solving absolute value inequalities, tell you what, just for the next few moments, let's see what we get for number 49, okay, whereupon we have 2 times the absolute value of x plus 3 minus 4, okay, is greater than or equal to 6. And also, let's say that in the case of number 60, let's see what we get for the solution, if any, for m, whereupon we'll have the absolute value of m minus 4 over 2 is less than 14. Okay, so for the next few moments, let's see what with these absolute value inequalities, let's see what interval solutions we get for x and 49 and m and number 60. Okay, if we look at number 49, okay, so here we have 2 times the absolute value of x plus 3 followed by the subtraction of 4 is greater than or equal to 6. And again, so the absolute value of x plus 3, okay, you're going to isolate that expression. So again, you do not distribute as you would if I had parentheses around x plus 3. Okay, so looking at what we have here, okay, we have just a couple of obstacles to isolating the absolute value of x plus 3. You have subtraction of 4 and the multiplication by 2. Okay, so I can start off, okay, by adding 4 to both sides. And so we have at this stage, okay, so we come down to 2 times the absolute value of x plus 3 is greater than or equal to 10. And we have in following through, okay, so we have a division by 2. 2 is positive, okay, so the direction of the inequality stays the same. And so now we have the absolute value of x plus 3 by itself, okay, and the absolute value of x plus 3 is going to be greater than or equal to 5, okay. And so if your absolute value term is greater than or equal to k, again, you'll have less than negative k, greater than k statements that will be established, okay. So at the lower end, on the negative k side, upon removal of the absolute value notation, okay, so we're going to have x plus 3 is less than negative 5. And on the other side, okay, we have the x plus 3 is going to be greater than 5. And since I have equal, okay, so I have equal signs for both of these. So I have x plus 3 is less than or equal to negative 5. X plus 3 is greater than or equal to 5. Okay, so looking at getting x by itself. So for x plus 3 is less than or equal to negative 5, and taking 3 away from both sides, we have that x is less than or equal to negative 8. As for x plus 3 is greater than or equal to 5. And if I take 3 away from both sides again, okay, this time we're going to have the x is greater than or equal to 2. Okay. So in looking at what we have now, Okay, so you have x is less than or equal to negative 8 or x is greater than or equal to 2. And the values, okay, which we're going to be focusing, okay, so we got negative 8 and positive 2 with the equal signs. Negative 8 will be part of the mix, so will 2. Okay, and so completing out what we have for each inequality. So for x is less than or equal to negative 8, okay, we have a ray going continuously to the left. And for x is greater than or equal to 2, we'll have a ray going continuously to the right. So you have non-stop motion both ways. So we have both negative and positive infinity involved. Okay, so for the interval solution, okay, we have with the separate sections. Okay, so we have at the lower end, we have going from negative infinity, approaching and including negative 8. And we have for x is greater than or equal to 2. Okay, so you have from and including 2, which, like negative 8, will also be bracketed. And we have going out to infinity. Okay, now, for what we have in the case of number 60, okay, so you have the absolute value of a fraction. You have m minus 4 over 2, all inside the absolute value notation. And this term is said to be less than 14. So this is a case where we have x is in a different letter and the expression is in the form of a fraction. It is less than k, where k is at 14. So with the nature of the inequality, upon removal of the absolute value notations, okay, I can set this up where in the format of negative k is less than x is less than k. In this realm, I want to have negative 14 is less than m minus 4 over 2 in turn is less than 14. And just taking care of the fraction. So I can take care of the fractions. I can just multiply all the terms out by 2. And I'm multiplying by a positive 2. Okay, so the less thans will remain intact. Okay, all right. So we have here, so got 2 times negative 14 is negative 28. And we have negative 28 is going to be less than m minus 4. And in turn, we'll have that m minus 4 is less than 28. And as we get nearer to solving for m, okay, we just have the subtraction of 4 to undo. And we have in the follow through. Okay, so if I add 4 to all sections, okay, so I have negative 28 plus 4. Okay, so this will make negative 24. And we have is less than m is less than 28 plus 4, which will be 32. And we have with the compound inequality. Okay, so we don't have negative or positive infinity involved in the interval solution makeup. Okay, so you have from negative 24 to 32. Again, neither value is included since we have the exclusion of the equal sign. And in terms of graphing, okay, we end up with a line segment that attaches the circles on -24 and 32. And so we have, in the case of the interval solution, we're looking at between -24 and 32. Again, -24 and 32 are not included, and so we're back to the exclusive use of parentheses.